Somewhere between the stars, a planet drifts through absolute darkness. No sun rises on it. No year passes. It was thrown out of its home system billions of years ago, and now it wanders the galaxy completely alone. A rogue planet is a world with no star. It doesn't orbit a sun the way Earth orbits ours. Instead, it moves through interstellar space on its own, untethered, dark, and for almost all of its existence, frozen. For most of human history, we assumed planets came packaged with stars. That picture is wrong. The galaxy is full of planets that belong to no one, drifting in the vast gaps between star systems. Estimates suggest there could be billions of them in the Milky Way alone. Some recent work argues rogue planets may actually outnumber the stars, meaning the most common kind of planet in the galaxy might be one we almost never see. You cannot photograph most of them. They give off almost no light. The main way we find them is gravitational microlensing, when a rogue planet passes in front of a distant star and its gravity briefly bends and magnifies that star's light. In 2011, a survey called OGLE, the Optical Gravitational Lensing Experiment, reported roughly 10 Jupiter-mass objects with no detectable parent star. It was one of the first strong signs that free-floating giant planets were genuinely common. These events are brutal to catch. A star-sized lens brightens a background star for weeks. A rogue planet does it for barely a day, sometimes only hours. Miss that window and the planet is gone, invisible again. In 2020, astronomers announced OGLE 2016 BLG 1928, a microlensing event lasting just 42 minutes. The best explanation is a rogue planet, roughly the mass of Earth or Mars, wandering completely alone. It remains one of the smallest free-floating worlds ever detected. There are two main ways to make a rogue planet. The first is ejection. A planet forms normally around a star, then gets flung out by a gravitational shove from a bigger neighboring planet or a passing star. Our own solar system may have done this. Many models of the early solar system require a fifth giant planet that was thrown out entirely during a period of chaos, sent into interstellar space before the surviving orbit settled. Those same models suggest that in the solar system's violent youth, rocky bodies as large as Mars were flung outward too. The galaxy may be littered with the discarded building blocks of planetary systems, including ones that never finished forming. The second way is that some of these objects form on their own, directly from collapsing clouds of gas, the same process that builds stars, just without enough mass to ever ignite. In that case, they were never planets of anything. That blurs the line between the biggest rogue planets and the smallest failed stars, called brown dwarfs, objects too heavy to be planets, but too light to burn hydrogen like a real star. Deciding which is still argued over. The rough cutoff sits around 13 times Jupiter's mass, where an object can briefly fuse deuterium, a heavy form of hydrogen. Below that, it's a planet. Above it, something else. But two objects of identical mass could have completely different origins. In 2023, the James Webb Space Telescope looked into the Orion Nebula and found something strange. Dozens of Jupiter-mass objects, many of them in pairs, drifting free of any star. Astronomers nicknamed them jumbos, Jupiter-mass binary objects. Nobody has a clean explanation for them. Standard models say objects that small shouldn't form on their own, and ejection shouldn't fling them out in neat pairs. Roughly 40 pairs turned up, and the disagreement over how they exist is still open. Some rogue planets we can see directly because they're young and still glowing with leftover heat. PSO J318.5-22, found in 2013, is about 80 light-years away, has around 6 times Jupiter's mass, and glows a deep, dull red. Another, CFB-DSIR 21490403, sits roughly 100 light-years off, and was one of the first free-floating planet candidates studied in detail. These worlds can have clouds of hot dust and rain made of molten iron, but no sun anywhere in their sky. The coldest known is WISE 08550714, about 7 light-years away. Its temperature sits somewhere around -20 to -40 degrees Celsius, cold enough that it may carry clouds of water ice, the closest thing to Earth-like weather found off-world. The atmospheres on the warmer, younger ones behave nothing like Earth's. Temperatures reach hundreds of degrees, driving winds of vaporized rock and clouds of silicate droplets. essentially molten sand raining out of the sky. A few even generate their own magnetic fields. In 2020, astronomers used the Very Large Array Radio Telescope to detect radio emission from a free-floating object, likely produced by aurorae, glowing bands of energy in its atmosphere with no star to power them. The surface of a typical rogue planet is among the coldest environments anywhere in the galaxy. With no star, the only warmth comes from within, leftover heat from formation and the slow decay of radioactive elements in the core. That internal heat may be enough to keep liquid water beneath the surface. A rogue planet with a thick atmosphere of hydrogen or a thick shell of ice could trap that heat like a blanket. That means a sunless, frozen planet drifting in the black between stars could still hold a warm, liquid ocean deep underground, sealed off from space and potentially stable for billions of years. Life there, if it exists, would never know the sun existed. This isn't pure speculation. We see the same principle inside our own solar system. Europa and Enceladus, moons of Jupiter and Saturn, hide liquid oceans under ice, kept warm without any sunlight. A rogue planet is that idea scaled up to a whole world. Any life in such an ocean couldn't rely on photosynthesis. It would need chemical energy, like the microbes clustered around hydrothermal vents on Earth's sea floor, which thrive in total darkness on the planet's own heat and minerals. A planet flung out of its system can keep its moons. The gravitational bond between a planet and its moon is tight enough to survive the ejection, which means a rogue world could carry its own miniature system into the dark. Moons still orbiting a sunless planet. That matters because a large moon around a rogue giant could be warmed by tidal flexing, the same squeezing that heats Europa. So the best place for life on a rogue world might not be the planet itself, but a moon orbiting it. Once ejected, a rogue planet can wander for the entire life of the galaxy. There's no orbit to decay, nothing to fall into. A world thrown out 4 billion years ago could still be drifting today, exactly as alone as the day it left. These planets are not drifting gently. They move at the speed of the stars around them, tens of thousands of kilometers per hour relative to us, on orbits around the galaxy that owe nothing to any nearby sun. A rogue planet could, in principle, drift straight through our solar system. Close encounters are rare but not impossible over long timescales, and a passing planet's gravity could nudge comets in the Oort cloud, the icy shell at the edge of the solar system, sending some toward the inner planets. We've already watched interstellar objects pass through, like Oumuamua in 2017 and Comet Borisov in 2019. Those were small, but they proved that material from other star systems regularly crosses our own. Larger visitors are simply rarer, not forbidden. Earth itself isn't immune. In simulations of the distant future, gravitational interactions or a passing star can occasionally eject a planet from a stable system. It's unlikely for us, but the mechanism that makes rogue planets is the same one holding ours in place, just tipped past its limit. The next leap is coming. NASA's Nancy Grace Roman Space Telescope is expected to find hundreds of rogue planets through microlensing, including small rocky ones, and finally give us a real count of how many are out there. Some estimates tied to that mission suggest the Milky Way could hold as many as 20 rogue planets for every star, a population reaching into the trillions. Most of them Earth-sized or smaller and completely undetected today. Despite all this, the confirmed count is still small, only a few dozen strong candidates. Everyone had to be caught in a fleeting moment, which is why our estimates of billions rest on a handful of lucky observations. Put the pieces together and the picture of the galaxy shifts. The night sky we know, stars with tidy families of planets, is only the visible surface. Between those points of light drifts a far larger, darker population we're barely beginning to count. A rogue planet is what a world looks like stripped of everything we associate with one. No sunrise, no seasons, no day. And yet it may still hold heat, weather, an ocean, and the raw conditions for life. The open question is whether any of those hidden oceans actually harbor life, and whether we could ever detect it on a world that gives off almost no light. A planet with no star breaks nearly every assumption we have about where life can survive. And the next generation of telescopes may be the first instruments capable of telling us whether some of these drifting worlds are quietly inhabited. If you want more space science like this, subscribe, and I'll see you on the next one.